Okay, this has always been a very interesting problem to me. And when I took the first look, I thought one way, and maybe I was right, maybe I wasn't. Refer to the figure below in which surge protectors P and Q are used to protect an expensive high definition television. If there is a surge in voltage, the surge protector reduces it to a safe level. Assume that each surge protector has a 0.94 probability of working correctly when the voltage surge occurs. Complete parts A through C below. If the two surge protectors are arranged in a series, what is the probability that the voltage surge will not damage the television? Well, if you think about it, if this one works, then the TV doesn't get damaged. If this one works, the TV doesn't get damaged. So in order for the TV to get damaged, both P and Q would have to fail. So the probability of failure is going to be what? It's going to be 1 minus the 0.94. Okay, well, I'm just going to pull up the calculator to do it. I'm mainly using this as like my little chalkboard here. Okay, so we got 0.06. That's the probability of the failure. Okay. Okay, they both have to fail. So the probability that for P that fails is 0.06. The probability that Q fails is also 0.06. So the probability that a voltage will not damage. So the probability that it will damage is going to be 0.06 times 0.06. Well, what do we have so far? We've got 0.0036. Now what we got when we did that? We got, how many zeros do we have? Let's clear that. That doesn't look right to me. 0.06 times 0.06. Okay, that's the answer that you got. That's the probability that they both fail. So it says, what is the probability that will not damage? This is probability that it will damage. So the probability of damage we found to be 0.0036. Well, the probability for it to not damage is the complement. So we would need to do 1 minus 0.0036. That's what you would need to do. And when we do that, what do we end up with? Well, 1 minus 0.0036. And what we got was 0.9964. 0.9964. Now, that's the answer we're going to put here. 0.9964. Let's see if we're right. Oh, yes, we are. Okay. B, if the two surge protectors are arranged in the parallel, what is the probability that a voltage surge will not damage the television? Well, it can go either way. You've got the probability it'll go through P, you've got the probability that it will go through Q. So you've got basically what you need is the probability of P working and Q. So you're going to need the probability that P and Q will work. Okay, the probability that P works is what? 0.94. And the probability that Q works is 0.94. Okay, so the probability that both P and Q work, you would need to multiply, and I'm just going to write this in parentheses so you can see it, 0.94 times 0.94. I put it in quotes so it won't do anything as far as the Excel is concerned. Now, let's pull this up, and we would say 0.94 times 0.94. And we got an answer of 0.8836. Now, let's put this in over here. 0.8836. Okay, before we go any further, which one was the best? The probability that it's not damaged, this is much higher than this. So this is the better way to configure your surge protectors. Which arrangement should be used for better protection? The series provides better protection because it has a higher probability of protection. You've got it two places, one was higher and one was lower. Okay, one of the longer problems.